All right, morning everybody. I'm gonna test this out and see how it goes. So the lesson I posted was called Factors and Zeros, and this is the last lesson for the last exit ticket in the packet. So just follow along and hopefully this works out. So remember, you should be doing all this in your notebook or your journal that you have. So do what you usually do. Make sure you have the heading down, you have the I can statement down, and of course make sure to pause me anytime you need to so you can write some things down, because I'm going to talk relatively fast since it is just going to be a video recording. All right, so what we're going to start off with is this idea of factored form. We've been doing quadratic functions in a couple different forms. Specifically, we've talked about standard form, which, if you remember, is ax squared plus bx plus c. And so remember that there's a quadratic term and a coefficient in the front, there's a linear term and a coefficient, and there's a constant form. And remember, this is not particularly useful. We can't do a lot with it. One of the things we talked about with this form was that, well, you could find the vertex. For example, you have the formula x equals negative b over 2a, and you get a number, and then whatever number you get, you take this number and you plug it back in here and here for the x's, and that's how you find the y coordinate. And so you'll get y equals whatever, and then at the end of the day, you have your vertex at v at whatever your x was, whatever your y was. So that's what we talked about in standard form. After that, we also talked about vertex form. Now, vertex form, if you remember, was particularly useful, obviously, for finding the vertex, but just in general for graphing of the sort. So vertex form was f of x or y equals a times x minus h squared plus k. So in that form, the vertex, remember, is at h comma k. So your vertex is at h comma k, whatever you have. That's an h. That's definitely an h. So that's where your vertex is. And remember, with this one, you go opposite the sign. With this one, you follow the sign, and you get a lot of things out of it, right? So this tells you like transformations. This is right or left. This is up or down. Remember, opposite the sign, follow the sign. The A is particularly useful if you remember. If it's positive, we know the quadratic opens up. If it's negative, it opens down. Absolute value greater than 1, that makes it skinnier or narrower, and absolute value less than 1, like a fraction, would make it wider. So that was vertex form. So now in the slide and in this lesson, we're talking about factored form. And so factored form is kind of like the simplest of all forms, and we've kind of been going over this without really talking about it. Factored form is simply when you take your quadratic, let's say it's in standard form, and you literally just factor it. So, you have your x squared plus or minus something something x plus or minus something something constant. And if you can, you don't have to, but if you can, divide out a constant in the front and then factor the rest of it. So there's one of your factors and there's your other factor. And so in each of these examples here on the left, both of these are in factored form. So just real quick, make sure you can identify all the pieces. So for example, in the first problem, k is going to equal 1. And we know that because there, if you look over here, right before the parentheses, there is no number in front of that set of parentheses. And so, of course, we assume there's an invisible 1. So the constant is 1. Our A is going to be 6 because we go opposite the sign. Remember, it's in parentheses. And then our B is going to be positive 1, also opposite the sign. So our K is 1, our A is 6, and our B is 1. So just take a minute, and on the second example, make sure you can identify it. Pause me if you need to. Take 5 or 10 seconds. 10, 9, 5, 1. Great. So you should have gotten that the K is 7, the A is positive 1, and the B is negative 8. And again, remember, it's opposite the sign. So that's pretty much it. That's factored form. There's nothing fancy or complicated about it. It's just another way of writing a quadratic function. That's literally all there is to it. All right. So on this form, we mentioned that, okay, well, if you have a parabola in standard form, and that's what this is up here, right? So if you have a parabola in standard form, this is what we did last class and last exit ticket. So talking about graphing it. And we found a bunch of things. So we used the formula x equals negative b over 2a, and we plugged that in, found the vertex, at least the x coordinate. Once you get that number, remember, you plug it back in, you find the y. So that's what we did there. Axis of symmetry up here. Same thing. Remember, the axis of symmetry is located at x equals whatever the vertex is, whatever the x coordinate of the vertex is. And then down here, remember that we found the y-intercept simply by plugging in 0 for all the x's. So you plug in 0 there, plug in 0 there, and really it's essentially whatever your constant term is. That's what your y-intercept was. We also, in the last class, started talking about the zeros. And the zeros, if you remember, were the same thing as the solutions, but also known as the x-intercepts. And if you don't remember, the way we found that was by using something called the zero product property, which literally says once you factor the equation, you're going to take each of those factors and set them equal to 0, and those are your x-intercepts. Those are your solutions. Those are the zeros. And so it's kind of obvious, but if you're in factored form, then the zero product property is kind of like a well, duh type of moment, because you're going to see, well, it's already factored, so why wouldn't I start with that? And it's basically just changing the order that you find things in, right? Because they're giving you the zeros. They're giving you the y-intercepts, the solutions. So if you look on the bottom right, it's already factored, so all you have to do is set each of them equal to 0 using the zero product property, and that's how you're going to figure them all out. So, for example, you have x minus 3 equals, wrong way, there we go, x minus 3 equals 0, and so add 3 to both sides, and you get x equals positive 3. You have x minus 1 equals 0, and so you're going to do the exact same thing. You're going to add 1 to both sides, and you're going to get x equals positive 1. Now, some of you might be wondering, okay, well, what about this thing here, the negative 2? If there's a k or a constant out in the front, we pretty much ignore it. I mean, if you think about it, does negative 2 equal 0? No, right? So that's why we can essentially ignore it. So anyways, we found our x-intercepts, our zeros, our solutions. Now, to find everything else, so to find the vertex, the axis symmetry, to find those things, what you're going to have to do is you're actually going to have to FOIL this whole thing back out. So I'm going to erase this, and again, pause me if you need to. But so what you would do, let me erase here a little slowly, sorry, using a stylus. All right, so right here. Okay, so what you're going to do is you're going to take these two terms and you're going to FOIL them back out. So x minus 3 times x minus 1, remember first times first, so we're going to get x squared, outside times outside, that's negative 1x, inside times inside, negative 3x, so that's a total of negative 4x, and then last times last, negative 3 times negative 1 is positive 3. So there we are, FOILed back out. Now we do have to use that negative 2. So what you're going to do is put that back on there, and you're going to distribute. So remember, distribute means you multiply everything on the inside times what's on the outside. So it's going to be negative 2x squared, positive 8x, that's an x, and then minus 6. So then, here's your A, negative 2, B, 8, C, negative 6. So I'll just write that down for you. It's A equals negative 2, that's a 2, B equals 8, and C equals negative 6. So you just take these two numbers, and you're going to plug them back into the formula like we did before to find the vertex. And of course, once you have the vertex, you have the axis symmetry. The only thing that you don't need to multiply back for, and again, I'm going to erase this, so make sure you have this if you didn't. If you look, I'm just erase this a little bit right here. So just for a minute, if you think back to factored form, you don't need to do all of this just to find the y-intercept. That you can still actually find back in factored form where we started. So if you think about it, what are you plugging in? You're plugging in 0 for the x, right? So this is 0 minus 3, so that's negative 3. Let me see if I can write this here. That's negative 3. Now this is 0 minus 1, that's negative 1. So if you think about it, this is like negative 2 times negative 3, that's positive 6, times negative 1, that's negative 6. So the y-intercept, we plugged in 0 for the x, and we got -6, and that was the y-intercept. So that is fine. All right, so on the next slide, here are two examples. We can't really do the I do, we do, you do thing on these, but go ahead and work these out. Specifically, I'm not going to bother going through the whole thing, finding the y-intercept, finding the vertex. I'm going to ask you to do that. So take your time, and again, pause the video, work them all out. And the easiest way to do this is probably going to be to do that and then call one of your friends, or you can even post your answers on Google Classroom if you get stuck. I can help that way. And again, remember office hours from 8 to 11. Otherwise, I'll check in periodically throughout the day. But again, here are two examples. So make sure you pause the video and work on these. If you need help finding the solutions, or if you think you might have gotten it wrong, please feel free to ask. All right, so again, all combined, all put together. I'm not going to spend too long on this, but zero product property, take each of the things, each of the factors, and set them equal to 0. And that is kind of what we're leading into with the next topics. Remember, this is the last exit ticket, the last lesson in what we're in now, topic 9. The next topic is going to be all about solving quadratic equations. So you have your x squared, your x term, your constant, whatever form you're in, standard form, vertex form, factored form, doesn't matter. But the next topic that's coming up is solving. And when I say solve, that literally means finding x equals blah and x equals blah. Keeping in mind that quadratics can have up to 2 solutions. Sometimes they have all 2 solutions, sometimes they only have 1, and of course sometimes they have no solution at all. But we'll get to that next topic. But what we're really talking about right now is the idea that, okay, if it's in factored form, this is like the most easiest, the most simplest, the most basic way to find the solutions to a quadratic equation. And I think every kid pretty much fundamentally understands this, right? So again, factored form, if it's in factored form, or if you can put it in factored form. Remember, sometimes it's not going to be factored for you. You'd have to factor it yourself. But if it's like that, just take each of the factors, set them equal to 0. With simple problems like the one here, you're going to realize that it's very, very basic. You can do it in your head in about 3/4 of a second. It's literally just opposite the sign, right? So if you take x minus 2 and set it equal to 0, how do you get the x by itself? Well, you do the opposite, the inverse, right? So you're going to add 2 to both sides, and you're going to get x equals positive 2. And here, again, you're going to get x equals -7. Now, it's not always going to be that simple. So what I want you to remember is that if you see like a coefficient, like in front of the x, if it's like a more complicated factor, then you should take the time, write it out, and go ahead and set each factor equal to 0 on paper, and then solve it. So don't try to do it always in your head. So here are some quick examples of that. And again, try these on your own. So pause the video, and I want you to try and find x equals blah and x equals blah, the zeros, the solutions, the x-intercepts for each of these problems. And again, pause the video to do this. Otherwise, these I can just give you the answers right now if you're ready. So the first one is going to be x equals 18, and the second one is going to be x equals 9. Notice that both of them are positive because the original problem, it was opposite the sign. So of course your x minus 18 equals 0, added 18 to both sides. That's how you got x equals positive 18, and the same thing for x equals 9. Here you should have gotten x equals positive 10 and x equals -18. It's a negative. And let me remind you that, of course, the 7 in this case does not matter, because when you write 7 equals 0, that's obviously not true. So you just pretty much ignore that. All right. So now getting to something a little bit more complicated, but once you get this, it's one of those things that I think most kids find cool, or like make you feel pretty smart for figuring it out. So the distributive property as it applies to factored form is not really distributive property. It's kind of understanding the opposite or the inverse of distributive property. And you can combine that with zero product property to solve equations. So go ahead and make sure you write this example down right there. So on the left side of the equal sign is kind of the problem, and on the right side of the equal side, the equal sign is the answer. And so I'm going to talk through this really carefully, just follow along. So notice that here are your terms, right? So you've got a term here, and you've got a term right here. Now, just by looking at them, you're going to notice something in common, and that's that they both have this term right here. They both have an x minus 4. And so what you're going to do is you're going to pull that out. So you're going to pull this x minus 4 and this x minus 4, and you're going to pull both of them out, and you're going to stick them by themselves. So that's the x minus 4. Even though they're separated on the left side, you're going to put them together on the right because both of the terms have it. It's kind of like you're dividing it out. You're pulling it out, the opposite of distributive property. Then you ask yourself, okay, once I've pulled out the x minus 4, what's left? So you notice in the first term, you have a 3x remaining that's left after you pull out the x minus 4. And in the second term, you have a 5 that's left. That's a positive 3x, and that's a positive 5. And if you look here, that's where they are. There's a 3x plus 5. So literally, you take what's common, what they both share, and you stick them to the side, and then you take what's left and you put them together and you stick them on the side. Now, basically what that's doing is you're taking a really complex problem, like what we started with, like you couldn't solve that on your own using any form. And actually, that's not something you're going to be able to solve in Algebra 1 normally. So you're taking that and you're simplifying it basically to something that you can work with, because now notice you have a factor times a factor. And from what we know, the zero product property says if it's in factored form, I can just take each of those, set them equal to 0, and find my answers. For example, now I have 3x plus 5 equals 0. Subtract 5, right? So I get 3x equals negative 5. Divide both sides by 3, and I get x equals negative 5 thirds. I do the same thing with x minus 4 equals 0. Add 4 to both sides, and I get x equals 4. So these right here, these are my solutions. These are my zeros. These are my x-intercepts. So of course, this is exactly what I'm going to be doing a lot of in the next topic. Okay. All right. So here's some practice problems. The first one on the top, I'm going to let you work that out on your own. And again, if you get stuck or have questions, just ask me. But the one on the bottom, I'm actually going to do for you. So you notice that here, they've already factored out the x plus 6. But over here, there is no x plus 6, right? So what you're going to end up doing is you're going to kind of have to ask yourself, well, okay, they didn't give it to me, so I can't do factored form. So obviously the logical thing to do is to just factor it yourself. So I'm going to rewrite it. So I'm going to leave my negative 7x, x plus 6. And what I'm going to realize is that, okay, if they pulled out an x plus 6 here, then they're going to pull out an x plus 6 here, right? So I'm going to kind of space it out. I'm going to write, okay, I'm going to assume they pulled out an x plus 6. Okay, so if I pull out an x plus 6, what's left? And logically speaking, if I divide this whole thing by x plus 6, all that's left is 5. And of course, there's going to be a plus in the middle because all of this is positive. They're being added. Now, check your work, right? So just think about it. If I were to multiply the 5 times the x, I'd go right back to the 5x. If I multiply 5 times 6, I'd go right back to the 30. So I know I factored it right. Now I see like, okay, well, now I have my two common factors. So I have my x plus 6, but what's my second factor? And you can write it in the front or after it doesn't matter. But my second factor is what's left. So I see a negative 7x, so there's negative 7x. And here's a positive 5, so I'm going to write plus 5. And again, this equals 0. So what you're going to do on your own, you're going to take this and you're going to set it equal to 0, and you're going to take this and you're going to set it equal to 0. And I'll just do the first one for you, and I'll let you work the rest out on your own. But it's negative 7x plus 5 equals 0. Subtract 5 from both sides, you get negative 7x equals negative 5. Then divide both sides by negative 7, and you get x equals 5. That's a 5 over 7. It's positive because a negative divided by negative is a positive. So just make sure you do the same thing with this factor. And once you're done with that, go ahead and do the example on the top as well. All right. So this is the last bit of practice I put on here before your exit ticket. So here there are 6 problems. Work them all out on your own, on your paper. Make sure you're comfortable with your answers. Again, call a friend, post your answer in Google Classroom, whatever you need to do. Go ahead and do it with questions, concerns, strategies to solve it, ways to make it easier. Anything you might have, just go ahead and do it. And then go ahead and start your exit ticket, which again is also posted in Google Classroom. And just make sure you either screenshot it, take a picture of it, do it on paper, upload it, whatever you need to do. Just show me that you did it, submit it into Google Classroom. That is due tomorrow, Tuesday. And what's the day? That's going to be March the 17th. Tuesday, March 17th is when that's going to be due. Okay. And then after that, just a reminder, the rest of the week you should be working on your topic 8-9 combo test. Same idea. Work them all out on paper, submit it, and that's all you have to do for the week. And that's it. Thanks.